Our next speakers, Alex and Jiska, will be talking about Apple's Rainbow Bridge for satellite communication, codenamed Bifröst. Alex is a PhD candidate and security researcher whose work focuses on proprietary protocols, such as Find My, ultra-wideband, and satellite communications. He's the person behind the AirGuard app, which is one way which you can find if somebody has snuck an AirTag into your bag and is tracking you surreptitiously. Meanwhile, Jiska breaks things, and her unicorn, which is typically wearing a tinfoil hat but left it at home, she started her own research group at Hasselplattner. And today, as I said, they're going to talk about talking to the stars. So let's have a huge round of applause for Alex and Jiska.
Thank you for this great introduction, and also thank you everyone for being here. And this room is crowded. Wow, so there's still a few seats left. But yeah, thank you. Today we are going to talk about Bifröst, which is a code name for the satellite communication in your iPhone, if you have an iPhone 14 or 15. So yeah, a little bit about me. I have a research group at HPI, so if you want to do some research with me, please feel free to contact, or if you have any questions. And with this, I'm handing over to Alex, who is going to tell you more about the basics.
Okay, so I'm Alex. I'm a security researcher and a PhD candidate at the Technical University of Darmstadt, and I like to look into new proprietary protocols. And here we looked into the satellite feature of iOS, and first we want to explain the code names here. So we have STUI and Bifröst, and STUI is basically a name for the satellite transmission unit, STU, and that's the iPhone, which is your STUI. And then we have Bifröst, which is a mythological name for the rainbow bridge from Earth to heaven. It's from Scandinavian mythology, and Apple uses that for the satellite communication. So what can you do when you have satellite communication in your iPhone? So one of the main features is that in any case of emergency where you don't have any cellular service, you have the option to contact emergency services over the satellite communication. And that works by filling out a simple form that describes your emergency, and then it sends your location and additional text messages to the emergency services, and they can reply to you and ask you things back. It's not about a phone communication, so it's all text-based, but it works pretty well if you are in case of emergency. A feature that has nothing to do with emergencies, but it's also added by Apple, is Find My over satellite. So when you are out and about on a big hiking trip and you're camping somewhere outside in the mountains, there's no cellular coverage, you can share your location with your friends over Find My. In the same way as you would do normally in the Find My app, but here you have to jump through some hoops and direct your iPhone at the satellite to do that. Only thing that has to be set up here before is that you have to have a location sharing ongoing with some friends. You cannot set it up while you're on the go. Another thing that's already there is the demo mode. It's used to allow people to train how they use the satellite feature. So for example, when you get into an emergency, then it's better to know how do I actually send the message to the satellite, because there are some things you need to consider, and the demo mode trains you to do that. You can find it in the settings and in the emergency SOS. Yeah, so satellite communication needs satellites. For this, Apple uses the GlobalStar satellite network. It's a vast network that has about 70 active satellites. It's not really 100% sure how many satellites are still active from the first generation, but basically Apple has bought in 80% of the coverage of this network. And they have ground stations and transmission units. The iPhone is one of these transmission units, so when you send a message to the satellite, it will forward your message to the ground station, which has an internet connection and then can do anything that's needed with the incoming message. And the cool thing here is that these satellites, they have been based in a designed in a future-proof way. They are basically called bent pipe satellites, so your message goes up and then it's like a bent pipe and it's just directed down. So it doesn't matter which encoding scheme or which modulation scheme is used. Apple can use the most fancy and current version, and it will still be compatible with satellites that have been launched 20 years ago. They're also called mirrors in space, so you can also imagine that as a metaphor for it. And when you send your Find My message, for example, to a satellite, then that satellite will just forward it to ground station. And there are about more than 20 worldwide. And this ground station receives the signal, and there's an Apple server placed there. So it goes directly through the internet to iCloud, and your friends, they can access the location from the internet. So that's how the satellite communication basics work. And now it's about how did we actually go and try to reverse engineer it.
Yeah, what reverse engineering options do we have? I know today there was a talk that I think they released a bug that will be useful for jailbreaking iOS 16 on iPhone 14, but when we did this research, this was not available to us. So what could we do on a non-jailbroken phone? So at least we can do static reverse engineering and stare at the logs. And Apple has a very useful tool that helps us with this. So there are so-called profiles or debug profiles that you can install on a non-jailbroken phone and increase the log verbosity. With the baseband debug log, you can even get all the bytes that are sent from the baseband daemon called CommCenter to the modem to instruct it to do certain things with the satellite. So here you can see such bytes from the log, but it still doesn't look very readable. So yeah, we get the bytes, but what do they mean? For this task, I had a very skilled student, Lucas, who is also giving a talk on the day 3 about rogue base station detections with just stock iPhones. And he developed a Wireshark dissector for QMI, including all the proprietary messages from Apple. So not just standard baseband, Qualcomm public QMI stuff, but really the internals that you need to understand the satellite communication. So your 5G modem will not only send 5G signals in the iPhone 14, but satellite signals. And it starts with a basic orientation thing, so you have to point your phone into a direction and tell the modem where the phone is pointing at, together with some configuration where the satellites are. So there's a lot of initial configs so that they find each other. And in the next protocol steps, we then have some security stuff, like some activation, some LLC key that Alex is going to tell you about, and the frequency configuration they are communicating at, and so on. Then we proceed with a registration step, do some more security config, or like get the security config with the LLC key confirmed. And once we did that, we finally say the modem, like, here is the message that we want to send, like the find my location. This whole thing with this activation, registration, and security config only happens when you really use it for find my. So this is something that will not happen in the demo mode. There's no actual data transmission. And finally, we will update the orientation a few more times, see a progress bar. It's never exactly accurate, like sometimes it just jumps from 30% to success. And once it's actually succeeded, we get an acknowledgement that the message with this ID has been sent. And finally, we close the satellite connection, like it drains the battery and stuff. So for Find My, we just send the location and then we go back to normal operation. But that, again, depends on your use case. So yeah, we have this dissector. We can look into it a bit, but still, like, this doesn't feel like reverse engineering so much. Like, how does it work internally? What did Apple do? And what can you do without a physical iPhone 14 jailbreak? Well, at least you can try Corellium. Here, because of the software configuration, the phone would think it has some sort of satellite features, even though this is like, it doesn't have a physical modem. But at least it thinks features are there. Luckily, we also got a security research device from Apple, but when you apply, you will always get the model from the year before. So we only had an iPhone 13 mini, which has no satellite feature. But it would be great if we can make this one think it would have satellite, so that we can do more testing together with stuff that we learned from Corellium. And for this, I'm now diving a bit into very technical internal components. So Alex told you can test the demo mode in the settings. So you get this special button in the preferences. And if you click on Try Demo, then there is an XPC message being sent to Com Center, which is like the baseband daemon doing all your telephony stuff, calls, internet connection. And this, in turn, uses a URL scheme to open an app with an argument like, this is the emergency tryout. And then Com Center and SOS Buddy will play a central role where both of them communicate with each other. So SOS Buddy is more like the UI, and Com Center keeps the state with the satellite connection. And even if you have the SOS Buddy app in background, Com Center will just keep going with those updates, and you might notice this pizza icon. So I think Apple was running out of wireless symbols or something. And yeah, so we have pizza since iPhone 14. And I had this idea, okay, so basically it's an URL scheme. We open URLs. So I just take a non-jailbroken phone, I make my own app where you can just open all the URLs that I statically reverse engineered directly. Surprise, it only works for the emergency tryout that we can already access through the settings. It doesn't work for anything else because Com Center is missing certain state and would just refuse to continue whatever you were trying to do with the SOS Buddy, because SOS Buddy state and Com Center state wouldn't match. So I was like, okay, how can I fake all of this until I make it to have a research device where I can look into this? So I had an iPhone 14, no jailbreak, but actually the modem that talks to a satellite. And I had a security research device. Again, not the modem, but at least it has iOS 16, which supports, at least software-wise, in theory, maybe a bit of satellite communication. I just wanted both. So yeah, how do you do that? Did you know that your phone has a radio personality? And the radio personality would tell the phone which features the radio has. Like, does it have satellite? Does it have 5G, 4G? And when this personality is created, you can look into the code, do a bit of reversing, naming things. You would figure out it loads the feature configuration from multiple places. One of them is, I guess, also very well known around jailbreaking, which is from libmobilegestalt. So this is a property list that basically tells a lot of properties that your phone has. And from here, we get a couple of properties like a hardware config, which is just a number that describes the model that you have, a bit more abstract, plus the actual name of the iPhone model that you have, and so on. And then there's a second thing where it takes certain capabilities off, which is the feature flags. And the feature flags are, again, just a property list that here say specifically core telephony Bifröst. So here's one of the many instances where we have some names. And yeah, so these two things, if they exist, we seem to have satellite enabled. So this is what I observed on Corellium and just try to reproduce on a research iPhone 13. on my first try, I was, okay, just replace the property list. But the issue then is that the iPhone 13 would try to load an iPhone 14 firmware that is not there, and even if you put it there, then like it just wouldn't really work, too many dependencies and stuff. But if you hook things up with Frida, then you can replace only the hardware config version in exactly this place and not the other places of Com Center, and that would help with the initialization of this radio personality. And luckily, on an iPhone 13, there's already the Bifröst feature flag. So in software, like almost everything is there. Then there's a couple of more hooks I had to do. If you want to see them, they're outlined in my OBTS talk. So Alex and me did a talk at Objective by the Sea, so there's just a couple of things there. But the most important part then is you saw all those logs of like the captures from the satellite. And because we don't have a physical modem that supports this communication, we have to hook a couple of things to make it believe like, yeah, the modem is taking everything. So we hook the send and receive direction to the baseband modem and fake some replies and hook a couple of messages. And when we do this, we actually get satellite on an iPhone 13 mini. So yeah, here you see it. So obviously this is not being sent to a satellite, but that's also a feature because now we can experiment with this without causing any emergency. So for me, that's a good thing. We can also try a couple of more features. So there is this emergency SOS. There is the tryout that you might have just seen yourself. Also an interesting thing that I guess many people are not aware of. Additionally, like when you have an accident, like there's a fall and a crash detection, and if that triggers, then there's automatically an emergency call being made on purpose of you, even if you're no longer consciousness or something. But here, if the normal mobile connection doesn't work, it would also try satellite. So that's the third feature. And last, there is the Find My, which is also like working very nice, and I got this to like really believing the phone that the location has been sent successfully. So yeah, that's all modes, and we can trigger them, we can research them, but now you might ask, okay, what doesn't even help if you don't have like a physical modem and just the phone with everything mocked? What kind of insight does this give to you? Well, there is one important thing, which is the Stewie and Bifröst configuration. So if you have Stewie available on an iPhone, it would configure a lot of things, and then you can research how it would take place. Like you cannot really look into those files from a software image because they are downloaded actually on the fly to configure your phone. And the first one of these is a so-called, like the Com Center has like a permission for entitlement that's called trial client, and trial is actually a trial daemon. And the trial daemon is super interesting. Like it would just download features or configurations from the internet. So without having a software update, just with a configuration update, Apple can decide that your phone is now getting certain beta features or certain configurations. And here we see a target property list and a config property list. Another thing this is what we see then. So here is some plotted version of the target property list. So we see actually where the satellites are. The config also contains like where ground stations are and a lot of other things. I think these two-line elements, they are only in there for around 30 days. So every now and then you should go online with your phone for this to work and to refresh the configurations. Another configuration there is that Apple tells you in the config property list in which countries and on which channels you can use the emergency over satellite features. So it's more like a software configuration, not really like an actual update. The last thing that's downloaded on the fly is even more interesting. So the comm center would contact the mobile asset daemon and tell, like, hey, I want to download a codec, and the codec would be for German or English language, and that's a compression codec for the specific language. So when you type some text to save some of the transmission capabilities, so that you are low in bandwidth, actually. And with that, let's look, how does this location sharing on top of all of this work?
Yes, so we've primarily focused on the Find My Location sharing to not cause any emergencies. And while we looked into that, I first wanted to understand, okay, how does normal location sharing work when you use Find My? So many people that have an iPhone probably know this feature. You can go into the Find My app, add some friends that can see your location for a day, for a week, for all the time. But how does actually their location come back to your phone? So the cool thing is, it's not that your iPhone continuously tracks you and sends the location all the time to Apple, and then your friends can just check it when they want to see where you are. It works like that when your friends request your location and there's no recent location update from your iPhone because your iPhone was using the Find My app, you will get a push notification to the iPhone, and that push notification triggers a service on the iPhone that will fetch the current location. And if the person wants to see your live location, it will start live location updates as long as they require to see it. So that will send then all your live locations back to Apple, and as soon as they arrive at Apple's server, they are forwarded as push notifications back to your friend, and this friend can then see where you are and get live updates for this. So here we can see my friend Jiska, she's in the conference center, so that's where I expected her to be, and to make this all secure, Apple decided to use end-to-end location encryption. So your location data that's actually shared to your friends is not visible to Apple. So every time your iPhone sends the location, it uses this ECIES encryption and a friend's key. These friend's keys, they are generated, and every friend has one key that all the other friends know. And with this key and ECIES encryption scheme, the location will be transformed into encrypted format. And in the background, ECIES is basically just a term that describes a range of encryption schemes, and in the end, this will be just AES in the GCM mode, so it's also secure from this side. That's a good idea, but how does it then work when you want to share your location over satellite? Because there are different problems. You cannot send maybe the full location data because it's too much data. And Apple has thought about this, but they also need to secure the satellite interface, because if I can just send anything to the satellite and the satellite will be overloaded, it's impossible for the people to use it for location sharing. So for this, they have these LLC keys, and they are generated up front. So that's an interesting thing we saw as soon as we onboarded our iPhone 13 mini to have the satellite features. It started generating these keys, and we saw them in the iOS keychain. So these keys are generated on your iPhone securely in the secure enclave chip. They never leave this chip. But of course, you can export a public key or use these keys for signing or encryption. And that's done during the initial provisioning. So for this, the iPhone needs internet access, because these keys are all shared with Apple. Your iPhone, I think, generates 30 of these keys, and each key can then be used for one satellite communication. And so to sync them, all the keys are uploaded to Apple, the public keys. And then Apple generates one unique key for each of your keys and sends them back. So you get a range of public keys from Apple. Your iPhone saves them alongside the keys that it has generated securely on its phone. And then you can see in the key chain, they are labeled Apple Com Center LLC. That's your private key. You can see there is no key information because it's stored, it's saying SE token, so it's in a secure enclave. On the right side, you can see public key from Apple, where you can see actual key information. And you can see that the key label matches on both sides. So you have one server key from Apple that is matching your private key. So what can you do with that? There's a very simple scheme. Elliptic curve Diffie-Hellman is used to generate a shared secret, which can then in turn be used to encrypt data, for example. So now you want to start and transmit your location to the satellite. So the next step that Apple has thought about here is they were like, okay, we need to reduce the data size, so they use a format called light location. In a light location, you still have latitude and longitude and an accuracy value, but you are not using double, you just use int32 values, and to do that, they just multiply it and convert it to an integer. And in the end, it's just 9 bytes of data to share your full location. But it's obviously not having your current speed in there, it's not having your elevation and things like that. So how does it look like? It's very simple. You just convert it, and then you have an integer value you can share. That's a scheme that's actually used in the AirTag, so it's not something Apple just made up for this one. So every time your iPhone encounters an AirTag that someone has lost somewhere, your iPhone will also generate a light location information and send that to Apple. And that's obviously not done to save bandwidth for the internet, it's done to save bandwidth on Apple's side. They don't want to have loads of location data in their database. It's enough to just have a very simple format here. So then the satellite transmission goes on. You have the friends key that we already know. It's saved on your iPhone, the light location, same encryption scheme, and then you have the encrypted format. Then your phone needs to transfer this to the satellite. So first everything goes to the modem, including your LLC keys, and then the modem does all the magic, sending it out to the satellite. Here, that's one area of active research, because Qualcomm modems, they're not ARM-based, so it's quite difficult to find out what actually is happening with the data, how it is sent out. Maybe they're doing some formatting on top of it, but that's what we're currently looking into. So then you have uploaded your location to the satellite. It's going down to the ground station and then to Apple's cloud, so your friends can access it. And that's basically how the location sharing on Find My works. Then when we go to emergency SOS services, there are different things to consider. So how do I actually start that? Might be interesting for you. So when you try to call emergency services and you don't have a cellular connection, your phone will try to use other cellular towers from not your operator. But then if they are also not available, then you will get a screen like we see here on the right side, where you can go to emergency text and you can start texting the emergency services. Or what happens when you have an automatic crash detection. That's what we see on the right side. It also starts to call emergency service automatically, but if that fails because we don't have a connection, it will try to send out a text over satellite immediately. And the cool thing here is it actually transfers additional information, because there's more things that are needed for emergency services. They want to know, obviously the whole questionnaire is going to be transferred, then all the text that you're sending. There's the initial text, what you can just see here, but then you go into a chat window so you can add more information. But also it always transfers your battery in a range. So if your battery level is known to them, so they know, okay, your battery is below 10%, so you might go offline anytime. So then they can use that. And then also location updates are sent continuously. And these are more accurate because you might be on the top of a mountain. So elevation data is relevant here. So it's also sharing that with the emergency services. But all this is using a very packed format. So they use a bitwise writer that writes each single bit to save as much space as possible. Then we thought, okay, how can we, or could someone misuse this satellite feature? Of course. Don't clap. Not yet. So what would be possible to do? So obviously we want to send messages for free because we have an ability that we can always use. We can share the location to our friends. It can only be used every 15 minutes, but we can still maybe send some text over this. Then the bandwidth of satellites is limited. That's why Apple is enforcing this 15 minutes limit. They have millions and billions of users, but obviously not all of them are doing location sharing over satellite all the time. But they have to limit it to some point to just keep the satellites working. So how could we then use text messages on location data? So when we have location data, we have values in the latitude from -90 to +90, and in longitude from 0 to 180. So we have these values here that we could use. That's 8 bytes of data. And we could basically map an alphabet on GPS coordinates. So when we use lowercase and uppercase letters and numbers, that would make up 62 characters. Then we have a 10-digit space that we could use. 2 digits could make up 1 character when we want to keep it very simple. So that would be 5 characters per coordinate, enough to write hello world, for example. So that was what we tried out. But then Apple was a bit smarter than us because the idea was, okay, you can set the location of an iPhone to fake location, and that fake location actually contains data that we want to share. But when you set it to a fake location, the iPhone knows that, and since we don't have a jailbroken iPhone 14 where we can actually manipulate data on the fly, this fake location detection would just remove us from using satellite communication at all, and this locked me out, I don't know, for like a week or 2 weeks out of using any satellite communication. So, and I was like, maybe in the city it's too crowded, I don't know. I go outside in the park, I tried lots of things, didn't work, and I think it was that thing. So Apple is smart here, and don't try it out because maybe you're in an emergency and then it doesn't work, that would be a bummer. So better wait for a solution, but the solution will be the iPhone 14 jailbreak, so when it is available, hopefully soon. And I think that's the end of our talk. Thanks everyone for attending it, and we have some time for questions, I think.
Great. For those of you in the room, you can see we have 4 microphones, 2 on the left and 2 on the right. Your left is not my left, but it doesn't matter. We'll figure it out. For those of you on the internet, we are monitoring Matrix, we are monitoring Mastodon in the Fediverse, and we're monitoring IRC. We are in the Granville room, so use the appropriate hashtags and IRC channels there. We have we have a bit more time than we thought, so we have about 6 minutes for questions, and let's start already with microphone number 1.
Hey, hello. Thank you for the talk. So my question is, you mentioned you're using AES GCM, but AES has a block size of 16 bytes. So I'd expect them to always be sending 16 bytes by satellite, right? So do they do that, or is it really just sending 9 bytes?
They actually send just 9 bytes as far as I know, but there is more data to be sent. For example, they also have to share the public key they're using for the encryption for the friends public. So ECIS also generates always an ephemeral public-private key pair. So the public key pair that's generated, or the public key of that pair, has to be shared as well. In the end, they are sending 83 bytes of data for this. But I think for the AES GCM, they keep it to the 9 bytes. Don't pin me on how or why. I didn't look into that.
Okay, thank you.
All right, let's go to the other side of the room in the front.
It might be a naive question, but since this is a redirector satellite, as you said, have you tried just sending in more data? Maybe they just pass it through just as well.
That doesn't work without a jailbreak.
Yes, but assuming that you will have the jailbreak and the reverse engineer will happen, and you would re-implement the protocol just without the iPhone, for example. If you wanted to...
Yeah, it's difficult to say because the satellite is just a bent pipe. So the whole logic of how things would be blocked or something is like all in the closed implementation on Apple's end.
Yeah.
So it might work, and we also tried to re-implement it without the iPhone, but the problem is the modulation here.
Yeah.
So we probably know which kind of modulation it uses, but we haven't managed to demodulate or modulate our own signals in this.
Okay, thank you.
Yeah.
All right, before we go to another question in the room, do we have any questions from the internet? And please, as you're leaving the room, try and keep it quiet so we can finish the questions and take any bottles you find or trash.
We do have a few questions from the internet, however, some of them may already be answered. So the internet is especially interested in the details of the physical communication with the satellites. So if you can go into any detail there, do we know the frequencies, the size of the messages, and any, would it be possible to look at the signal with, say, an SDR receiver or something like that?
So yes, it's possible to record the signal with an SDR. We did that. It's around 1.6 gigahertz, the frequency. That's the normal frequency for all ground to satellite communication. So that's where you would expect it. And you can find more information about, for example, which modulation scheme it uses in the FCC reports from Apple. So there is some information there. So it's also possible to record it, probably possible to send it, but the problem is modulation is not always easy, so there's some things to be done to finish this. Yeah.
Microphone number 1.
Yeah, you mentioned that you create 30 encryption keys and share it with Apple. Do I assume correctly that after using those and not having internet, you can't send any more messages out?
Yes, like there is, I think, 30 or so keys, but there's also last resort key, and probably that's then being reused. Have you tried exceeding the limit yet? Or
I know that one of our students tried it, and he was not able to send messages anymore, but it also could have been because the iPhone hasn't been online for like 2 weeks, 30 days, and it didn't know where the satellites are. So yeah, probably you can still send messages with this last resort key.
Okay, so this is like valid for like unlimited messages until Apple decides, yeah, that's
yeah, there is always one key where it marks, okay, this is last resort.
Okay,
yeah.
Perfect, thanks.
Do we have another question from the internet? Maybe.
We do, yes. Question, is there any information on how much Apple pays to GlobalStar and whether iPhone users will be charged for this feature in the future?
no.
They plan to charge people, but I guess not for emergency services, but I don't have any information.
Yeah.
Microphone 1, again.
You mentioned that the satellites send the data to some sort of base station. How does this base station know from which iPhone the request came from?
The base station itself probably doesn't know, but the server in the base station from Apple can receive the message, decode it, and then find out, okay, it's signed, we don't know if it's signed or encrypted by this LLC key that has been shared with Apple before. They're always linked to an Apple ID, so Apple knows, okay, it's this Apple ID that has sent this message with even this device. So there's also some information saved on Apple's side, so you don't have to transfer your Apple ID, for example, with the message.
All right, thanks.
And do we have time for one final question from the internet?
Maybe one question is if I send the public key to Apple, which is then forwarded to my friend, can't Apple generate its own key and send their own public key instead to my friend? So basically do a man-in-the-middle attack to that communication so that they can decrypt their location, the location sent.
Depends on how they share the keys, I would say. So I haven't fully found the place where the keys are actually being generated and shared. I just know they exist, and when they change, and when they do not change, for example, they don't change if you leave one of your friends is kicked out of your friends list. No, then they are changed. But when you add one, then it's not changed. So things like that I know, but I don't know how they are generated. So I cannot say if Apple could sneak in there.
All right, let's give a warm round of applause and thank you for Alex, Jiska, and Jiska's unicorn.